Okay, welcome to Lecture 17. Now that we're done learning how to balance reactions, we are going to do some mathematical work with them. That means doing stoichiometry. Now, stoichiometry comes from a couple of Greek words. We have stoichion and metros. So stoichion means element, like an item or a piece of something, an element of something, and metros just means measure. So we are measuring the pieces. Okay. Now this has to do with relating the different parts of a chemical reaction together. Okay, so looking at hydrogen plus oxygen makes water. We're relating the reactants to each other. We're also relating the products to each other and the reactants to the products. We're relating every piece with every other piece. Okay? And what this reaction is telling us is that two molecules of H2 react with one molecule of O2 to produce two molecules of H2O. You could just as easily replace molecules with moles. So 2 moles of hydrogen react with 1 mole of oxygen to produce 2 moles of water. You do a little bit of conversion, and what you could get would be 1 gram plus 8 grams makes 9 grams. And remember, you have to do your mass to moles conversion. You have to work with the formula mass, the molar mass, in order to get that to work. Now, what if you had, look here in the upper right, what if you had 6 molecules of oxygen? How many molecules of water could you produce? Well, you look here, you see 2 to 1. And you're going to get twice as many molecules of water out of it as you put in oxygen. So you can get 12 molecules of H2O. That seems simple and straightforward enough, yeah. But let's go ahead and make it formal. Okay, let's find a way to write it all out so that we can try to avoid making mistakes. In order to do that, you need the stoichiometric factor. Okay. That's a conversion factor from one element of a reaction to another. So, for example, that's 6 molecules of oxygen is how many molecules of H2O? Well, the conversion factor comes right out of the balanced reaction. Where you're going to goes on top. Okay, so for this particular reaction, you're going 2 molecules of H2O, so it's 2 molecules of H2O for every 1 molecule of O2. So the conversion factor will always be made up of 2 different parts, and each of those is the coefficients found in the balanced reaction. Okay, so that's how we get 12 molecules of H2O. For every 6 molecules of O2, molecules of O2 cancel out, you're going to get 12 molecules of water. So let's look at a different example. We're going to be throwing a lot of math at you with this one because we're going to start with, how many grams of oxygen are needed to completely react, let's call it 15.00 grams of propane. First, you need the balanced reaction. So, C3H8 plus O2 yields, this is a combustion reaction, so CO2 plus H2O. This is technically a redox reaction, but combustion reactions and single displacement reactions, you don't need to do that big, messy, formal, step-by-step redox thing. So let's go ahead and balance it. Use the less messy formal method. So we have 3, 1, 8, and 2, 2, and 3. So multiply this by 3. 6 plus 1 is 7. Multiply this by 4. 8. 6 plus 4 is 10. And then we multiply this by 5 to turn that into 10. All right. Now it's balanced. So, all roads lead to mole. You can't convert directly from grams to grams. You have to go through moles. Okay? So, 15 grams. We need to convert that to moles. So, times moles of propane, gram of propane. So that means we need the molar mass of propane. Molar mass of propane is 12.01. That's carbon. There are 3 of those. And there are 8 of the hydrogen, 1.008. So it's 36.03 plus 8.064 is 44.09 grams per mole. And so 1 mole up top, and what that gives us for our math is 0.3402 moles of propane. And now that we have moles of propane, we can go ahead and convert to moles of oxygen. So, times where we're going to goes on top, where we're coming from goes on bottom. So moles of propane. And this is just the coefficients taken directly out of the reaction. 5 and 1. 1.701 moles of oxygen. We're almost done. Not quite. I said how many grams of oxygen. So we're going to have to go ahead and do another conversion. We're going to multiply by the molar mass of oxygen. Grams of oxygen per moles of oxygen. And that's 32.00 grams per mole. Gives us 54.43 grams of oxygen. And there's the answer to that little question. So what this means is that you have moles in the middle. You can convert from moles to mass using, formula mass. You can convert from moles to atoms or molecules or formula units using Avogadro's number. If you know the volume, let's make that a V. If you know the volume, you can convert to molarity, or from molarity, I should say. And then, so for any participant in a reaction, reactant or product, you can do that. And then you can convert to moles of a completely different substance using the stoichiometric factor. Okay, and that's just what comes straight out of the reaction. Then for moles, you can convert to mass or molecules or molarity, whatever it takes. So let's go ahead and look at a different sort of reaction. Okay, what volume of 0.250 molar HCl is needed to neutralize 25.00 liters of 0.500 molar calcium hydroxide. So we've got a couple of steps to do. First off, we balance the reaction. HCl plus CaOH2 goes to form CaCl2 plus H2O. This is really straightforward to balance. We just needed 2 right there. And another 2 right over here. Okay. So, next up, we need moles of calcium hydroxide. Okay. We have volume, we have molarity, so we can get moles out of that. So 0.500 moles per liter times 25.00 liters. Liters cancel. That's going to leave us with moles is 12.50 moles of calcium hydroxide. Now we're going to have to do a stoichiometric conversion to get to moles of hydrochloric acid. Everything goes through moles. So 2.50 moles calcium hydroxide times moles HCl moles CaOH2. Where you're going to goes on top. It's a 2-to-1 ratio. So that gives us 25.00 moles of HCl. And now, with moles and molarity in hand, we can find the volume of HCl we're going to need. 25.00 moles HCl. We can go ahead and treat the molarity as a sort of conversion factor. It's moles per liter, and it is a molarity of 0.250. Oops, that should be 12.5, 12.5, 25.0, 25.0. That's what I get for not paying attention. And what that's going to give us is 100 liters of HCl. It's a very large quantity. So that was a neutralization reaction. So let's see if I can't give you another general form. You have reactants going to products, for whatever reaction. Okay, so let's call it substance A and substance B. Okay. So I can ask you about anything, a reactant or a product, going to, how much is necessary or how much will you make or whatever for a different reactant or product. So no matter what, I'll give you some quantity for substance A. And then you'll do whatever conversions are necessary to get that down to moles of A. Everything goes through moles. Then you convert, using stoichiometry, to moles of B. And whatever I asked you for, that's what you convert into that quantity of B. So it could be mass, I could just ask for moles, or it could be molarity or anything like that. Okay. So you just look for the conversion factors you have, look for the reaction you have, balance it as necessary. And that is it for this particular lecture. Stoichiometry is going to be really important, so this is another thing you're going to have to practice. I'll see you next time.